All right, hi everybody. My name is Mary Snow, and today I'm going to be talking about the event loop and some cool performance hooks that came out as with Node in Node 8.5. I came from sunny Southern California, so this weather has kind of been a shock for me. But it's been interesting having to wear a jacket. That's new. OK, so let me just go ahead and dive right in. So when I first started learning about Node and the event loop, there were a lot of terms that were coming to the forefront that I didn't necessarily know what they meant, or I had heard of them, but I didn't really know exactly what they meant. So a lot of these were like the call stack, the V8 engine, Libuv, the event loop, and the task queue. So if it's your first time seeing these and you're just trying to understand how to build an application, it can get kind of confusing. So my goal here is to break some of these things down so that when we start talking about performance hooks, you have a clear idea of what is really happening under the hood, and you can utilize them a little bit better. So the question I want to ask is, what happens when our code runs? How do we keep track of the thread of execution? And what we do with synchronous code is we reference the call stack here. So I'm going to go ahead and run through this example here. So the call stack is a stack data structure that keeps track of function calls that are being made. So stack works with first in, last out. So imagine if you had an actual stack of plates and you wanted to get to the bottom plate, you'd have to take them off one at a time in order to get to the bottom. So that's our stack. So the calls to the top of the stack must be popped off before the ones below it can be popped off. So we'll go ahead and run through this example here. Notice that there are three functions. We have a function third, second, and first. And then finally, at the end of the file, there's a call to function first. So once first is called, we're going to go ahead and push this call onto our call stack. So first is pushed onto our stack. And then we go ahead and move inside the function body of first, where we have a console log statement. Console log will get pushed onto a stack and then evaluate. So we should be logging, I've never made the same mistake once. And once this is done, this gets popped off of the stack. We then move to our next line of code, where we have this return second function. So we're making a call to the second function, which means we need to move. We need to push our second function onto the stack, and then go ahead and move inside of that function, where we have this console log statement. I make it 4 or 5 times. This gets pushed to our stack. When it's done evaluating, it will be popped off. And then we move down to third, and the same thing happens here. So third gets pushed onto the stack. We move inside, we execute, and we have this console log statement, which is just to be sure. So we log this. Gets popped off. And then we don't have an explicit return here. We have an implicit return. There's nothing else inside of our third function. So we're going to go ahead and return out of this function. And so our function second is actually returning our function third. And so when this happens, third will get popped off of our stack. And then we'll move back down to where the function second was called. That's returned. So then second gets popped off our stack. And the same thing for first. So you can see that the call stack is really just helping us keep track of our function calls and what is being executed. So I want to move into sort of Node and how it works under the hood, and we'll come back to this idea of a call stack in just a minute. So Node is built using 2 separate dependencies. These dependencies are the V8 engine and Libuv. So the V8 engine was built originally for Chrome browsers. And you've probably heard of these at some point in time working with Node, but maybe you've never looked into them. So we're going to go ahead and look into them a little bit right now. So the V8 engine is responsible for transpiling your JavaScript code into C++ code, and then assembly code, and then machine code that's going to actually interact with your physical machine. This code has built-in optimizations, so you don't need to worry about things like garbage collection or memory allocation. This is all handled for you, which is really nice as a JavaScript developer. So those are things you don't need to worry about. The other dependency of Node is Libuv, which according to Wikipedia stands for Unicorn Velociraptor Library. But funny enough, I couldn't actually find a reference to that on their website. I tried looking for it and I just couldn't find it. So I'm not sure what's up with that. But the more you know, I guess. So Libuv is written in C++, and it has a focus on asynchronous I/O. So great, what does that mean? What does I/O mean? So I/O stands for input and output, and an I/O is an I/O task collection, which is the time it takes to complete a computation. And that's determined by the period of time that you spend waiting for a computation to complete. So you're waiting for this I/O process to finish. So in an I/O-bound task, there's a bunch of wait time for a response to come back. Typically, this could be from a network, a file system, a database, these types of things. So Libuv is processing these I/O tasks through either the operating system or its own thread pool. So in a Node application, when one of these I/O tasks occurs, this doesn't stop the rest of our program from running. Imagine if you made some sort of I/O call, you wouldn't want your application to just cease until this response came back. So we want to avoid a lot of waiting, and so this is kind of where the event loop comes in. And so we're going to go ahead and look at what is happening in the event loop. And this is coming from the Node docs themselves. So Node provides us with this simplified overview of the event loop order of operations. So each operation is referred to as a tick in the event loop. You've probably heard of next tick. And they go in this order. So we start specifically at the top with timers. So inside of the timers phase is where the callbacks scheduled by set timeout and set interval are executed. And then from there, we go into the I/O callback phase. And this is where almost all of the other callbacks are executed. So the ones that are not executed here are the timers, which have their own tick phase, and set immediate, which is also in another tick phase. And timers, set immediate, and close, which is also handled in its own tick. So then this is idle and prepare is an internal Node piece used internally. But then we have this pool. So this is for Node is asking, sorry, I thought I moved too far. So this is asking for incoming connections. So Node is basically saying, do you have anything for me? Did I get anything back from this connection? So that's what's going on here in the pool phase. And then there's a check phase. So inside of check, this is where any set immediate is going to be evaluated. And then finally, at the end of all of this, we have a close event. So here in this phase, you might think of an example as like a socket on close. That's where this callback is going to be evaluated. And we'll keep going through the event loop as long as we still have processes that are being evaluated here. So, and again, this is a simplified version from the Node docs. So we can get way more in depth, but I'm going to spare you those gory details and go into this example. So what if everything ran on the call stack? What if nothing was passed into Libuv or the event loop? So we have these two set timeout functions, and in the middle, there's a console log statement. So what would happen is we would set timeout, and then we would wait a minimum of at least 5 seconds. But it could always be longer. It just has to be that minimum of 5 seconds. And then once we're done waiting, we'd execute the callback, which has our console log statement, and then we would log out this waited 5 seconds, and then we would pop all of these functions off of our stack. Then we move into console log, which should evaluate normally. So it gets pushed to the stack. We evaluate it, get hello friends, then it's popped off our stack. And then we move to our last set timeout, where again we have to wait at least the 1 second, and then we'll go ahead and call the callback function, console log statements. So we get waited 1 second, and then these all get popped off of our stack. So that's really not the way things are executed in JavaScript. If you were to run this code inside your browser, you would not get it in this order. So what's going on is a little bit different. So here is an example with the event loop. So if you're familiar with JavaScript and the way it's going to run, you already know what the order is going to be. So we should get hello friends, followed by waited 1 second, followed by waited 5 seconds, right? So what happens is a little bit different. setTimeout is invoked. And instead of waiting and clogging our stack, this is actually going to be passed to our Node API and handled there. So it kind of goes away in this other place. And we'll have some more details in the next slides. So it's going somewhere. It hasn't just disappeared. But our stack is no longer clogged, so we can move on to this console log statement, which will evaluate to hello friends, and it gets popped off our stack. Second set timeout is called, and again, this is going to be evaluated over in the Node API. And once whichever set timeout function has finished evaluating first, in this case, it's the 1 second one, the callback function will actually be pushed to the stack. And then after that, we'll have our console log statement, which will log waited 1 second. These items will get popped off our stack. And then we'll do the same thing for the first set timeout that took 5 seconds. So we'll have our callback, console log, waited 5 seconds, and then these are both getting popped off of our stack. So what's kind of going on in between when it seemed like magic was kind of happening? This is the same example. So we're going to invoke the set timeout, and we're going to pass set timeout. So Libuv is going to take care of this inside of the event loop, which is part of the Node API. So we're going to pass it over to the event loop, and it's going to execute there. And so we're waiting for that to happen inside of the Node API. We can still finish with our call stack, so we keep going. We have our console log, hello friends, which evaluates, gets popped off. Then we call our other set timeout, which is also in our Node API. Great, so now we've waited the minimum amount of time. Our timer has gone off for at least 1 second. What happens now is after this callback is evaluated, it has its own queue. So it gets placed to the queue. So the event loop will put this on a queue. And then from there, the event loop checks to see if the call stack is empty and if there's anything on the queue. So if both the call stack is empty and there's something on the queue, it's going to go ahead and move this callback into the call stack. And so the event loop is responsible for this movement. And then this will evaluate like you would think. We get our console log statement. It would be the waited 1 second. These get popped off the stack. Again, once we wait the 5 seconds, we take this callback function and put it on the task queue. The call stack is empty. We have something on our queue. So we'll go ahead and push this function onto our stack and then evaluate it like normal. So that's a little bit about how the event loop is working and how the call stack is kind of helping us keep track of our function calls, even with the event loop and the event loop task queue. So now that we have this sort of background, I want to go ahead and start talking about some of the interesting changes that occurred in Node 8.5. So Node 8.5 was released last year, I believe in the fall-ish. One of these changes that happened is that Node gave us access to performance hooks through the performance timing API. So something to be aware of, though, is that these performance hooks are classified as an experimental feature with a stability of 1, meaning that they are subject to change at any point in time or even removal. So I was hoping that they would not be classified this at this point in time, but what can you do? But with this in mind, it's still a fun feature that gives us a lot of information to work with. And so what's included in Node 8.5 in terms of the performance hooks? So according to the documentation, the Performance Timing API provides an implementation of the W3C Performance Timeline specification. And the purpose of the API is to support a collection of high-resolution performance metrics, which is the same performance APIs implemented in modern web browsers. So naturally, when I saw this, I didn't understand what it was saying. So I went ahead and went to the W3C site, which I took a screenshot of here, and started looking at the performance timeline. And then I went through the Node documentation, which is far too long to take a screenshot of, so I've just typed it up here for you instead. And you'll see that a lot of things are in common. So the Node performance hooks give us this class performance. We also have performance interface in this W3C performance timeline. We also have Node entry, or performance entry, I'm sorry. And then we also have this performance observer. One thing that you'll notice that's different is performance hooks give us access to this class performance node timing, which is an extension of performance entry. So what is that and how do we use it? All right, so in this simple example, I want to get access to some information about the event loop inside of NodeJS. And using the performance module, we can gain access to node timing. And you'll see from what gets logged to the console that we have access to a variety of different metrics. And it's a lot to take in. So what I like to focus on are actually just the loop start and loop exit performance metrics. So we have a loop start time, which is referring to the event loop, and a loop exit time, also referring to the event loop. Notice here that our exit time is at 0. So I didn't want this to happen. I wanted to see the actual exit time of the loop. Why would this be happening? The reason is that we just haven't exited the event loop yet. So if you remember the diagram from the Node documentation about the event loop, and I don't have a photographic memory, so I figure I put it up here again. the timers are executed in the first phase of the loop. So the timers get executed first, followed by I/O callbacks. This is internal, then we have polling, then we have checking, and then we have close callbacks. So this close is where the event loop is going to close. So we need to wait until we reach this last phase, closing phase, in order to get access to the end of the event loop. So I went ahead and I've slightly changed the function from earlier. So inside of setTimeout, I'm using process on exit. And process is a node global that provides information about the current node processes. It's not something that's new to Node, and it's separate from performance hooks. But in order to get the loop exit time, we need to wait until after the loop is finished. So we're just using process on exit. And then afterwards, we'll just go ahead and make this console log statement. And you can see that we get the loop start and the loop exit time. You also have another option. You can listen to a before exit event instead of just an exit event, which sounds kind of counterintuitive. It sounds like before exit would be before the loop is finished exiting. But that event is actually emitted when NodeJS empties the event loop. So you have got some options here. But either way, now we have access to the loop start and the loop exit time. OK, so we also have access to a bunch of other information here as well. So inside of this example, in order to utilize the performance module, first we need to gain access through to performance and to our performance observer. And so we're just going to require those in through the performance hooks. And then we have a simple function here called SumFunction. This is taken from the Node.js docs. So you can find it probably still, but again, it could be updated at any point in time. So it's just a simple function that's going to console log hello world. And then here's where things get interesting. We instantiate this variable wrapped, and we're going to call performance.timerify, and we're going to pass in our function that we want to get our performance metrics on. So we wrap our function by calling performance.timerify and pass in the function that we want. And so then down here, we're going to create a new performance observer. And this is going to take in a callback function. And we'll go ahead and jump into this in just a minute. I actually want to kind of jump down into this obs.observe. So in order, the performance observer that we have here, it's got to be subscribed to the function event type, which is what's going on here. So we have an object entry types that takes in an array, and we're passing in, we're saying we want a function. And so we need this in order to get the timing details. So this is important. And if you wanted to use any sort of performance observer, you would need to pass in an entry type. It is a required field, and there are a few other entry types to go into. But I'm just going to focus on functions for right now. OK. And then once we go back, this is what's going to console log our screen. This will console log the duration to our screen. And then we're going to go ahead and run a disconnect. So if we were to run this disconnect function here, or call this disconnect method, and we had multiple functions that we wanted to observe, we would only see that first call because we've been disconnected. And then we can clear the functions from our function from the timeline by calling this performance.clearFunctions. So at the end of all of this long mess of code, we go ahead and call wrapped, and that's going to log our hello world and also give us a duration. So that's great, but there's also, we're just getting the duration, and I wanted to let you guys see the entire performance entry. So I went ahead and just called the entire entry here. So you're going to get the name, which is referencing the function, the entry type, which is a function, the start time, and the duration. So if you wanted to find the end time, you could always reference, take the duration and the start time and perform some mathematical calculations. One thing to keep in mind also that you may have noticed is that performance is not consistent. So in my first example, when I ran it, I had this duration. The second time I ran it, I had a different duration. And so what changed? I was console logging something slightly different, the whole performance entry versus just the duration. But I decided to run this 5 times, actually probably a lot more than 5 times, but I'm only going to show 5 times. And the duration changed every single time. So if you are using any of these performance metrics and you want to have access to this data, it might be better to take some sort of average rather than just taking one instance of your performance timeline. OK, so you can also use the performance observer with multiple functions here. So I've taken the example provided in the documentation and changed it a little bit. So I have we have our function count, or we have a function SumFunction. I've created a function count. which is going to recurse until the number is equal to 0. Don't pass in a negative number. I didn't account for that here. And then I also have a timeout log, which is going to set a timeout and return hello world. I've also wrapped these functions. So on the top right, I've wrapped those functions with performance.timerify. So I wanted to get the performance metrics here. And the only thing that's changed inside of the performance observer is that I commented out the disconnect method. That way we could actually see all the performance entries. Again, if you disconnect after it runs once, you won't get any more data. So I went ahead and logged everything here. One thing you'll notice is that when I call the second function, which is count, with the wrapped count, I have to pass in something. So I pass in the number 6. And then inside of the performance entry, we actually get an extra piece of data. Instead of just starting out with name and then the name of the function, we'll actually get a 0 and then as the key, and the value is 6. So 6 is what's passed in, so that's our key. So that's kind of interesting, but you can definitely use performance observers with multiple functions. OK, so I think I kind of ran through that faster than I intended to. In this talk, I've talked about the call stack, V8 engine, Libuv, and the event loop. Just started scratching the surface on the performance hooks in Node. There's only been a few Medium articles that I was able to find about people who've been experimenting with these and posting what they found online. So if you'd like to explore, I think it's a really interesting area, and there's a lot of crossover that you can do with performance hooks and async hooks together, which is pretty interesting, but it is experimental at this point. So I don't know how much time you'd want to spend, but I think it's an exciting feature, and I'd love to play with it when it gets more stable. So thank you.